Okay, so again, I'm really sorry for the technical difficulty that occurred. So the media site could not record the video that was done in lecture hall, but it's the same thing I'm doing right here, right now. So I'm sorry if you feel inconvenient watching this. Um, I will try to record the video, but I think this might help at this moment, and I'll make sure that media site doesn't do that thing again. All right, guys. So we were talking about polynomials. So polynomials is um, a function or an expression that is arranged in this form. So remember, you have to have positive integers for all these powers. Okay, and so for example, 5x to the power 3 minus 3x squared plus 2x minus 7 is one of these examples of a polynomial. So in this lecture, we will learn how to factor and how to expand or distribute polynomials. So there are two main things we can do. We can factor polynomials and we can distribute polynomials. Okay, so let's just talk about some naming things. So these things, the numbers in front of the variable, these are called coefficients. Okay, and this last number has a special name. It's just called the constant. And this first number also has a name. It's called the leading coefficient. Now, remembering the names of these concepts is somewhat important, because in the future, when I want to refer to it, I will just say leading coefficient and you should know what I'm talking about. Okay, now there are different types of polynomials, monomials, like 2x squared is a monomial, just one term. Binomials, two terms, 2x squared minus 5, that's binomial. Trinomials, 2x squared plus 7x minus 3, or 5x to the power 7 plus 3x plus 2. Whenever there are three terms, it's called a trinomial. So we will focus on these type of trinomials, which are called quadratic trinomials. Okay, and when you write a polynomial in a standard form, you will have the powers of x in descending order. So for example, x squared minus 5x cubed plus 7x5 minus 2 is not the standard order. If you need to write it in standard order, bring this to the front. So that is 7x to the power 5 minus 5x to the 3 plus x squared minus 2. That is in standard order, or the standard form. And then just the 0 is called the zero polynomial. Okay. All right. So let's just talk about this naming. So this is not an puzzle video. This is not graded. So if you can it's optional to watch this. Okay. So let's see whether these things are polynomials or not. Now this one right here, it is a polynomial. It is negative 2x to the power 0. So it's a 0-degree polynomial. It has a degree 0. And it's already written in standard form. Now this one right here, you can see when you rewrite it, minus 1 plus 3x to the power negative 1. When you rewrite it, you can see that it has a negative exponent here. So this guy is a negative exponent, which means this is not a polynomial. Okay, so negative exponents are not allowed, and fractional exponents are not allowed in polynomials. So for example, this guy right here, plus 4x minus root 2 x to the power 1/2, that is bad. It's not a polynomial. Okay. And the last one, if you look at the powers, well, it is. All powers are integers, which means it's fine. It is polynomial. So that would be root 3x to the power 8 minus 4x 5 plus 5x minus 7 is the standard form, and you can see the degree is equal to 8. So evaluating or substituting means just plugging. So plug in the given numbers, that's it. Okay, so let's say when x equals -2, plug it in, -2. So you get 2 times -2 cubed plus 3 times -2 squared minus 2 times -2 plus 5, and that should end up at -16 plus 12 plus 4 plus 5. That is 5. And you plug in 0. You get 2 times 0 cubed plus 3 times 0 squared minus 2 times 0 plus 5. That's 5 again. And last, let's plug in 1. So you get 2 times 1 cubed plus 3 times 1 squared minus 2 times 1 plus 5. That's 8. So quite straightforward. You can simply plug in any values. Okay, all you need is just to know how to add and multiply those numbers. Now that's plugging in things. Even addition and subtraction is not something really bad. You can just add the like terms, or you can just subtract the like terms. So let's see how that go. So just find what the like terms are. So right here you can see like terms, like terms again, and then like terms. So just write down all the terms and combine the like terms. So x cubed plus 6x squared plus 3x squared plus negative 4x plus 2x plus 7 minus 4. So just add it up. X cubed plus 9x squared minus 2x plus 3. That's it. Okay, and let's find the difference. The same thing, same principle goes. Just combine the like terms. So x cubed plus 6x squared minus 3x squared, 6x squared minus 3x squared. Okay, and then minus 4x plus 2x, minus 4x minus 2x, and then plus 7 plus 4. So that would be x cubed plus 3x squared minus 6x plus 11. Okay. Multiplication follows the distribution rule. So for example, right here, just distribute or just combine these two. That would be negative 18. And then combine these two, x to the power 8 times x to the 5. So negative 18 x to the power 8 plus 5, that is negative 18 x to the power 13. When we multiply two binomials, we use something called FOIL. Okay, so how do you use FOIL? You just do the first term, you do outer term, you do inner term, and then you do last term. That's FOIL. Okay, so first terms you get 2x plus 2x times 4x, 2x times 4x. That's first. outer terms, you get plus 2x times 7. Inner terms, that's negative 5 times 4x. Last terms, that's negative 5 times 7. So that would be 8x squared plus 14x minus 20x minus 35. So you should end up with 8x squared minus 6x minus 35 as your answer. Okay. So that's that. You know how to multiply two polynomials, two binomials. So even for polynomials, you just use an extended version of FOIL. Okay. All right. So let's see. There are some things, some shortcuts that you can use. One of them is the difference of two squares. The difference of two squares, just remember the formula. You can actually file it and see that formula works. Okay, the correct formula is u squared minus v squared. Memorize this. And the formulas for square of binomials is u squared plus 2uv plus v squared. And u minus v perfect square is u squared minus 2uv plus v squared. And this is, remember, this was discussed in lecture 0 part 2, that is called the freshman stream. Don't do it. Okay. All right. So let's see how we apply this to this single example right here. Use the formula. Okay. So the formula gives you u plus v squared is equal to u squared plus 2uv plus v squared. Okay. So let's see how this works here. Now, according to the formula, when you compare this, you can see this is your u and you can see this is your v. So the formula reads as u squared, that would be use parenthesis squared, plus 2 times u is 3x, v is root 5, and then last one is root 5 squared. So you end up with 9x squared plus 6 root 5 x plus 5. Square root of 5 squared is 5. So that's the end. There's no further simplification, and that is the polynomial you're looking for. Okay. So let's move on to cube. Now again, what's really important here is the formula, not the way you obtain it, unfortunately. So what you can actually see that this is just foiling 2 times. But let's try to remember the formula. U cubed plus 3u squared v plus 3uv squared plus v cubed. It's something you need to memorize. Now, the other one is cube of a binomial but cube of a difference. That's u cubed minus 3u squared v plus 3uv squared minus v cubed. So you can see the difference is the negative sign is alternating in the second equation. Okay, so let's apply this. So you can see we are using the second formula, which is the difference cubed, and your x is u, your v is 2. So applying the formula, it's x cubed minus 3u squared, that's x squared times 2 plus 3x times 2 squared minus 2 cubed. So negative sign was originally in the formula. Okay, so x cubed minus 6x squared plus 12x minus 8. That would be correctly simplified. Okay, so up to now we learned something called expansion. Okay, and the opposite of expansion, going from here to here, is called factoring. Okay, so factor a polynomial. To factor a polynomial is to express it as a product of its prime factors. So a polynomial is factored completely if it's written as a product of prime polynomials only. Okay, so let's see. So factoring can be quite tricky depending on the question. Okay, so there's not just one technique that you use to factor. There are several techniques. So you have to look at the question itself and think about how to factor things. All right. So let's look at this one right here. So first thing is look at the greatest common factor. How do you find the greatest common factor? Factor things to prime factors. So 24 factors are 2 to the power 3 times 3. 36, the factors are 2 to the power 2 times 3 to the power 2. So when you pick the greatest common factor, what you do is, it should be the common factor. So the bases should be common. So that's a common base. 3 is a common base. But also we have to pick the exponents. For the exponent, so use common bases. Do not write uncommon bases that are not common. And 2, pick the least exponent. That's it. So least exponent. So now we have 3 and 2. The least exponent is 2. And we have 1 and 2. The least exponent is 1. So the greatest common factor is 2 squared times 3. Oh, here in this case it's 12. Okay, so very similarly you can do find the greatest common factor of two monomials. Okay, so let's find the prime factors. Here you have 2 times 3 times x cubed y1 z1. Here you have 2 times 3 times, okay, there's no 3 here, sorry, 2 times 3 times x squared times y squared. Now write the common bases. Do not write anything else. Common, 2 is common, x is common, y is common, z is not common, and 3 is not common. So only things that are common goes to the greatest common factor. And look at the powers. 1, so powers of 2, 1 and 1, least 1 is 1. Powers of x, 3 and 2, least power is 2. Powers of y, 1 and 2, the least power is 1. So 2x squared y is the greatest common factor. Okay, now let's move forward. But before that, let's do one question here, and I'm gonna have a look at actual lecture notes to see whether I went wrong here. If that is the case, I will upload it with the correct note. So let's see how you factor 2x cubed yz minus 6x squared y squared. Okay, so you already found that the greatest common factor is 2x squared y. So what you do here is you will write down 2x squared y and try to fill in what's missing. So you have x cubed. Here you wrote x squared, so an x is missing. You had y, you have y here. You had 2, you have 2 here. You had z, you don't have z here, so write it down. And then minus. Write down the common factor again. 2x squared y. Well, you had 6. Now you have 2, so you need 3. You had x squared, you have x squared. You had y squared, now you just have y, so there should be a y here. So now you can see in red, you can see the common factor. In green, you can see the uncommon ones, not common ones. Okay, so what you do is you take out the common factor and write down what's remaining inside the parentheses. So xz minus 3y. Okay, let's move on. Okay, here. Look at the greatest common factor. The greatest common factor in this case is, well, we are looking at 3x squared and we are looking at 2 times 3 times x. So common bases are 3 and x. The least powers are 1 and 1. So 3x is the common base, greatest common factor. So write 3x and x is missing. Write 3x, 2 is missing. Okay, now you can see 3x is the common factor. So you can take it out. And then inside, open a parenthesis, should see x minus 2. Okay, so let's see number 2 here. In number 2, you can see, well, it's a little long, but you can still find what the GCF is. But before doing that, let's actually rewrite this. Now, 8 can be written as 2 to the power 3, x to the power 4, y to the squared. And 6 can be written as 2 times 3, x3, y cubed. And this can be written as negative 2 xy 4. Okay. Now let's see the greatest common factor. 2 is a common factor, yes. So 2 should go there. X is a common factor, should go there. Y is a common factor, so that goes to the base. And now let's pick the least exponents. 3, 1, 1, 1. 4, 3, 1, 1. 2, 3, 4, 2. So 2xy squared is the greatest common factor. Okay, now let's do what we've been doing. 2xy squared plus 2xy squared minus 2xy squared. Okay, here you had 2 to the power 3, which is 8. Okay, so that would be, what's remaining is 2 to the power 2. X to the power 4, you took out 1x, so x to the power 3. Y squared, you took out that, and see whether this is the same as this. And it is. Let's see what happens here. 2 is good. There is a 3 that's missing. X cubed, you have x, so you should have x squared. Y cubed, you have y squared, so you should have a y. And the last one, 2 is good, x is good. Y4, you have y squared, so you have a y squared here. And now you can see 2xy squared is the common factor, open the parenthesis, 4x cubed plus 3x squared y minus y squared is the factorization. Okay, so that's how you factor that. All right, so let's go to the next one, which is using the difference of two squares and the difference of the perfect square trinomial. Okay. So the difference of two squares. Again, what is important is the formula, and that is u minus v, u plus v. The perfect square trinomial is u squared plus 2uv plus v squared factors as u plus v, the whole thing squared. And u squared minus 2uv plus v squared factors as u minus v, the whole thing squared. Now let's see how you factor this. Okay, so how do you identify that this is one of those forms? Well, two terms squared and a minus. That begs you use this. Okay, so this is your u and this is your v, and this is of the form u squared minus v squared. So the factoring is u minus v, u plus v, and your u is x plus 2 minus y, x plus 2 plus y. So that would be x minus y plus 2, x plus y plus 2. Okay, and this one right here. Now it's three terms, and you can see these two are similar. Okay, and you can see that this is x, this is 4 squared, and this is x squared, and this is minus 2 times 4x. Okay, so your u is x and your v is 4. So you can factor this as x minus 4, the whole thing squared, and that's it. Okay. Okay, so I would end the lecture right here because I can defer you to the bonus lecture in Edpuzzle from this page onwards. I will actually try to merge these two into a single lecture and put it on Canvas. So thank you for watching.